Yep.
Awesome. So, welcome to Tech Labs and Bytes. It's great to have you on our podcast. So, before we go deep into database, Murali, I mean, you have an excellent resume on database. I mean, you have
Yep.
pretty much been doing this for over 2 decades now, which is awesome. And
Yep.
of course, you are a lead database engineer at Apple. And but again, I'm sure so many people will want to really know your journey. So,
Yep.
would you be kind enough to walk us through your journey? How did you really fall in love with database?
Sure. Yeah. So first of all, thank you very much, Castle, for giving me this opportunity. Uh, yeah. Yeah. It's already 2 decades. Yeah. Thanks for reminding that. Yeah. So yeah. So like anybody, I started my career. Before that, I completed my masters in Master of Computer Applications,
Okay.
and then selected for a campus interview. At
Okay.
that time I was like, not sure in which path I'm gonna, like, my career is gonna go.
Mm-hmm.
So I was like, in a first company I was trying as a software engineer. You name
Mm-hmm.
it, .NET, Java, HTML, database, everything we tried within, like, first 4 to 6 months. And
Yeah.
then I started loving, like, even my loving to database and operating system, these two, not like started in my career, during my college days also. I used to love a lot the data and database and operating system together.
Okay.
But coming to the database, I really like that very much, like, so the way you represent yourself or your company or anything is like, data.
Mm-hmm.
So I, I just started my career as Oracle database back in 2005, and surprisingly, by this month, May, I'm like,
Mm-hmm.
20 exactly. You mentioned 2 decades. Yes, it's like, 2005 May. I passed out Masters of Computer Applications. Exactly
Oh,
20 years, and
oh,
August 1st was the day started my career.
happy
Um,
anniversary.
Thank you, thank you. Really appreciate it, and glad that I'm, sharing my experience and going to have fun with you here.
Yeah.
It's very good. So that's how I started my journey over there. But coming to the database, so I realized after a couple of years, the
Mm-hmm.
data in the world we are getting in a different farmers, like, and I kind of envisioned, so the traditional financial kind of data, the traditional the IBM or like traditional Oracle databases, kind of like an enterprise database solutions are
Okay.
there. But I envision data is changing. The social media is gonna come up, like, in 2010 or 2011ish, like after 5 to 6 years of my career,
Okay.
everybody was busy in deep dive going into Oracle, and they wanted to set up their career in Oracle itself. That's
Yeah.
where I thought, like, let me think in a different way. The data is coming in a different way, looks like, and the size, the variety of data is gonna be. So how we will handle such kind of data? So I thought, okay, let me think differently and see
Mm.
what kind of different databases we can explore, and what kind of different problems we can solve. So that's where I realized there is something called distributed database system.
That.
And yeah, and like, NoSQL, Cassandra.
Mm.
I explored. I went ahead to the management. I said, like, hey, I would like to basically explore different database. Then one of my directors said, oh wow, that's great. So I have seen people in Oracle, like, decades, and they don't want to come out of that. And
Uh-huh.
it's very comfortable, right? If you are at Oracle, so it's enterprise. If some issue comes, you just create an SR and they will provide the solution. So that is
Absolutely.
something also poking me. So
Yeah.
I don't want to be like, execution of commands given by somebody. I
Yeah.
would like to be part of that journey also.
Mm.
So that gives me not only Cassandra, after
Yeah.
Cassandra, the open source
Oh,
technologies, so such
great.
as PostgreSQL, so like
Mm-hmm.
MySQL. So
Mm-hmm.
that's where like these 2 decades, I would say it's a wonderful journey. But
Okay.
yet, even though out of this 20 years, my journey
Yeah.
at Apple almost 17 years,
Okay.
a couple of years as a contractor, 12 plus years as an employee. Every
Mm.
3 to 4 years, I used to go for a challenging project, which is like new database technology.
Wow.
So yeah, so I envisioned like if someone comes to me, I should be able to guide them or guide the application team the
Yeah.
right database, right decision. So be it
Yeah.
a performance point of view, be it a financial point of view, anything.
Yeah.
So
Yeah.
that basically drove me until here, and still that is something. That I keep on thinking about it, like look for
Mhm.
something new, look for envision what it's gonna be in next 5 to 10 years.
Awesome.
So that drove me crazy, and because and it has its own negatives too, but I took it as positive. So because if you are in a one technology and Apple, so you can have like your work life balance, you can enjoy because it's like the environment very much. But every
Yeah.
3 to 4 years, I was keep on changing my technology, like my database career. So it's kind of
Uh-huh.
like a startup. Every 3 to 4 years, I'm into a new startup. So yeah, I think I learned lots of experience in this journey. So if I would have stopped at one particular technology, I would
Yeah.
have not learned this much, not exposed to this much.
Yeah.
So I'm so grateful for the opportunities I got it, and also for the mentors, for the Apple especially. So
Yeah.
at, into Apple, the journey it was like little fun. I will share later. So yeah, that's
Awesome.
it. That's it from my. Hmm?
Okay. Awesome. I mean, that's such an inspiring story.
Yeah,
So, just because you mentioned Apple, obviously we are in the AI era,
correct.
and so we know it's no more the future. Like AI is actually here to stay.
Exactly.
And and we are seeing the real value that Apple is doing. Recently, I turned on my Mac laptop and I had the new Apple Intelligence on my
Oh,
laptop. So
yeah,
it's
yeah.
not all, we have moved from just asking Siri questions like, "Hi Siri," now we can actually prompt, which
Nice.
is awesome. And
Yeah,
also, the fact that I could just pull up my Apple Intelligence and just kind of like read a bedtime story to my kids. I think that
great.
is really, really great. Yeah, absolutely. Um, but again,
And also, if you follow the news, right, recently, I
mhm,
think early this week,
yeah,
Apple, there is a news that in Safari also they're gonna
mhm,
introduce this AI search, and
okay.
yeah, yeah. So we are advancing in every software and hardware. Yeah,
Oh, that's cool. Okay. So there's just so much integration going on, with generative models that Apple is really doing a lot of great job. But
correct.
again, we know that AI would not be able to do all of this without a trusted database, right?
Yes.
So is it like, generative models is kind of like trying to take all the credits and database are just at the backstage doing all the heavy lifting? And so basically, my question is, how is this even possible? Like we have so many users of, Mac products out there, how are millions of people using the new AI fixtures and are able to prompt it and retrieve really quick results from a database?
Yeah. Actually, that's a very good question. Uh, it's also a popular question these days in every
Mhm.
interview. If you go, like any
Okay.
FANG interview or any go, there is something called system design interview these days. So I
Yeah,
feel like the question you asked me is like a system design
even like
question
a
for me.
step design question. Yeah.
But yeah, like any, I think the core point for us is
Mhm.
we know the ecosystem, like the front end and
Okay.
middle layer and the database layer. So this is like the traditional three-way approach. Still, we are following the same thing, but
Okay.
depends upon the needs. Depends upon like be it like AI, generative AI models. So
Mhm.
and for me, especially for me kind of people, so I told back in MCA, like Master of Computer Applications, so this
Okay.
AI is now becoming so popular, but
Yeah.
we have learned about artificial intelligence, data warehousing, and big
Hmm.
data. So all these theoretically back in 2000s, so we
Okay.
learned about all this, it's been there in books. So
Yes.
and in this last 10 years or 20 years, we also
Yeah.
database also evolved, not like a traditional Oracle database. Sorry, I'm quoting Oracle because that's
Yes.
where like popular at that time. So
Yeah.
it has its own lots of limitations, challenges. So
Okay.
because it depends upon the acid properties, atomicity, consistency, isolation, and durability, it
Hmm.
restricted itself. So
Hmm.
whether it's a number of transactions wise, so whether it's the
Hmm.
database size wise, because if it goes lots of database size, so and also it can't handle, it can't give the throughput what it's supposed to. So
Yeah.
then we came up with this like distribution database, open source, all these databases, right? So these kind of databases are really helping us to handle such kind of high transactions, high throughput of data. So
Okay.
and also the on top of database there is something called LLM, right? Like unit language, language models. So you
Okay.
need to train your database in a way
Okay.
that you provide customer or you provide the consumer the right answers, whatever they needed, at least the accurate, like 99%, like 99.99%. So
Okay.
it needs like lots of engineering behind the scene. So
Okay.
but that's how the not the people who are behind these technologies been
Uh-huh.
having like me and other people know the
Uh-huh.
theoretical part of artificial intelligence. That is like one
Mhm.
side, and second side is
Yeah.
like the ecosystem already, last 2 decades, the way the ecosystem of initiating a request until you fetch from the database, this entire
Yeah.
journey is evolved. And the lots of like LLM kind of like engineering efforts, all these three together, we are able to achieve that, the artificial intelligence implementing in, be it in a hardware, be it in a software. So that's what I can say. So yeah.
Thank you so much for sharing. I mean, that's just been really, really great because, of course, sometimes I'm kind of like, how are they able to do all of these things? And it's just great to know
Yeah, so
the
basically
time.
I would say first of all that is our job, and second of all,
Okay.
at Apple, or
Yeah.
even like me, kind of some people, we have some responsibility, the
Yeah.
world, we are like taking the money point of view, anything like we are taking, so what we are giving back to the society, or what we are giving back to the these people. So we should always
Yeah.
think in that direction, the innovation part. So
Yeah.
that makes Apple different than other companies, right? So that keeps on drives us.
Absolutely. I totally agree on the innovation part. And, that brings me to another question about Apple. So sometimes I would turn up my iPhone. I'm an iPhone user. Not like I have
Yep.
anything with Android, though. Not like I have anything with Android users, but I am an Apple user. So sometimes I turn on my iPhone and suddenly, like a photo pops up, right? Of, it could probably be like there was a time a picture of when my mom was teaching me how to cook, and it kind of like made me feel, oh, Apple, like this was such a long time memory. Like you guys are just giving
Yeah.
me, good memory vibes. And it feels like, Apple has built a really good digital time machine with that
Yep.
for them to actually
Yeah.
go
Yeah.
back to, you know, and, the great thing about this is that it does not only, preserve great memories, but it's the fact that it also uses geolocation. So it kind of like tells you where that photo was taken, which I thought was really, really, really nice. So my
Yeah.
question is,
So please go ahead.
okay, so basically, I'm just kind of wondering how is that database architectures, to make sure that, all of a sudden, Apple just reminds you of something that happened years
Yeah.
back.
So
And then,
yes, you're right. Yeah.
yeah,
So definitely, even in my iPhone, sometimes when it pops up like, hey, like 10 years back, you were there with your family in SFO Golden Gate. So that like gives a very wow, like, kind of moment, like, you're in middle of something, some work, some busy, some tension, and that kind
yeah,
of pop-up gives you, like, spend some time there. And I try to minimize the entire graph and say, oh, in United States, how many states we covered so far? Okay, let's try something else in future. So that is
yeah.
something kind of like a customer kind of experience. But behind the
Okay.
scene, as you rightly mentioned, geographically, so when
Hmm.
we have the data,
Hmm.
so it's not like earlier, like, long back, the data is like kind of only for a retrieval. Either it
Okay.
is a select retrieval, or
Hmm.
something changed, and
Okay.
do the DML kind of operation. So the databases
Okay.
were so popular for either selecting data or
Okay.
the DML operations, but the request was initiated by the customer. So that was the days back. So
Okay.
now the days are gone, like, now the database
Okay.
requirement is like, you have a database, so
Hmm.
automatically you need to send the data to data warehousing or big data or analytics. So it has to drive derive a conclusion or solution, or for
Okay.
your business needs. So for the administrative management, they need to do some business decisions. So
Okay.
how they do, like, by using this data.
Okay.
Also, that is one that's how it started. So then, for
Okay.
customer satisfaction, why can't we do so? We have the data, so we have to just, like, aggregate, see, like, when that photo has taken. So how frequently this user is going to some particular location. So you will have the all those timestamp, everything. So you can
Okay.
aggregate. That's what the artificial intelligence we built in the phone, right, or in the technology. So
Okay.
it takes care of. So that what I'm trying to say, like, the traditional database was only meant for the customer initiate a request and then
Okay.
serve the request. So now things
Oh,
changed. On top
okay.
of that, we before customer asking, we try to provide so much of data, provided the security part. So so we don't want to be looking into your too much personal data. That is
Yeah.
Apple is there. So provided
Yeah.
that, so we're trying to give the customer experience, so before they
Okay.
ask. So
Awesome.
actually, for to design that, it's like lot
Yeah.
of efforts behind the scene. So we need to design a lot, because we don't know what will give customer a satisfaction, because we are going in a dark silo. Like, if you ask a question, if I know what you want, I know how to
Okay.
satisfy you in that aspect. But I don't
Okay.
know what things can satisfy you. So I need to think about that, and then provide
Okay.
something and make sure you're happy. So
So basically, you are saying that it is integrated with AI. That's how
yeah, so obviously,
that's how
yeah.
it reads, that's how the images pop up, pretty much.
Correct. So this AI, like the Siri, especially, like, the talking Siri or something. So
Mm-hmm.
now it's so popular, Janai, but it's been there, like, more than a decade at Apple. The AI
Okay. Yeah.
integration.
Awesome.
Yep.
That is good. So, I mean, so that brings me to my next questions. So, say you have yourself a one-to-many relationship in your software application, right? And it's just like saying, well, I've got a pizza with many toppings. But also, too, you just want to allow some users to see some of your toppings. Like you don't want everyone to see some data.
Yeah.
Now, maybe you decide that, oh, okay, let them see just maybe the cheese or the pepperoni.
Yeah. Yeah.
And so basically, my question is, how would you slice up your database, to make sure that you don't turn a pineapple into a pizza, a pineapple on the pizza debate, and
Yep. Yep.
make sure that people only get to see what they need to see from the database
Yeah.
structure? Yeah.
Yeah. That's a very good question actually. So that comes under the security. So
Okay.
that's where, like, some of the database technologies itself
Yeah.
provides the security baselines. So
Okay.
yes, you might have seen I am like a database security lead too, in
Okay.
multiple database technologies. So but
Okay.
I can tell in a layman word, like this part comes under security. One level
Okay.
is the database technology which you choose itself has these kind of security rules and baselines defined. So
Okay.
on top of it, we also define the tables, the views. There is something called view, which is like very
Oh,
traditional. So you will have
okay.
table, but the view
Yeah.
is part of it. So depends upon the user. So that's what we proudly say, like, security is like we don't want to see or this one. And also
Yeah.
the data is encrypted, so no one can see the real data, even though
Yeah.
we have access to the data. First of all,
Yeah.
that security layer is high level. And then to the individual users, there is something called, what I can say, authorization and authentication. So there are like two popular words. So
Uh,
that's so. So whether this particular user is authorized to use the database or not, like, by the authentication. And
okay.
then the authorization is like, okay, this particular user now logged into the database, so he is known user. But once he
Uh,
logged in, how what are all the tables, or what are all the synonyms, what are all the objects he can access. So that
mm-hmm.
is something called authorization. So we define
Mm-hmm.
that authorization in the database level. So by, like, rules, by creating, there are like so many things are there to segregate in the way this particular user is a right user, and this particular user should be able to see what he has to see, what he or she has to see. So there are like two
Absolutely.
ways. One is the database itself provides some tips and tricks in security, and as an organization, so we will also do lots of implementations from our side.
Awesome. Awesome. It's great to know that authorization and authentication can definitely solve this problem.
Yes,
Absolutely.
yes.
Uh, so, I mean, if you were on a mission to build the next big software masterpiece for Apple, for example,
Uh-huh.
uh,
Mhm.
what would you need to extract? And probably you would need to extract, from a database. You need to do maybe the whole ETL process. Um, Now, when it comes to extract, transform, and load, what's the secret sauce for efficient data extraction when building the software masterpiece that you were doing?
So the data extraction, right? So the secret sauce for anybody, like, any system design,
Yeah.
there are some databases are
Okay.
IO bound. So, like, IO bound in the sense, so you need
Yeah.
to go to any request or any data you try to gather.
Okay.
The database needs to communicate to the disk where the data is reside. So that's
Okay.
like very costly. So because always disk IOs are very costly. So you might have know, in our old days, like we used to call, not old days, in our college days. I don't want to use the word. So yeah. So there is something called RAM and ROM, random access memory, read only memory. So So the core, the beauty of our computers, right? So the era we are, the
Yeah.
core is same. Whatever you learned, the core 20 years back, it is same. We are trying to reutilize or like regenerate like all these things. So
Okay.
there is some technology called memory based.
Okay.
So it's kind of like memcache. So
Okay.
always the cache technology is very awesome. So the
Okay.
popular caching methodology is Redis. So
Mm-hmm.
we tend to keep the caching layer before any request hits to the database. So but provided if you don't design the caching very nicely, you will end up
Mm-hmm.
with like negative issues.
Absolutely.
So the way like the frequently used data or
Yeah.
the huge data, so you
Yeah.
need to like keep that rules at the caching layer. So
Okay.
also there is one more database. There is something called which I worked on it. MemSQL, not MySQL. It's Memory SQL. The
Nice.
database name changed to single store now. It's a
Okay.
columnar memory based. So to get conclusion, whether it's a Redis cache method or this memory based single store,
Yeah.
so the caching is key. So whether the caching is at the load balancer level or
Yeah.
caching at the application, the web application level for the
Level.
scalability,
Yeah.
or the caching at the database layer. Or
Okay.
what I would suggest is like the last point I would suggest is like, so what if the caching is there before even you go to the load balancer of the technology. So
Mm.
nowadays the application, the app in your phone or mobile, that will
Yeah.
have some percentage of cache. For example, your application is like 300 MB, the app
Mm.
you downloaded. So there is like 2 to 3 percentage, 5 percentage of cash dedicated there. So
Oh,
before you go to the load balancer and application server database layer, all this route s- locally itself you have available the frequently used data, the local analytics like hey, you open this app and you're trying to buy this object, or you're trying to search for these kind of objects, so you will get automatic
yeah.
suggestions and everything local itself. So that is actually game changer.
Oh, awesome. It's good to know that catching solves all the problem when it comes to ETL. So that's really great. Okay, so and from catching, that brings me to another question, and this is about because I think in your previous answer you mentioned NoSQL. Well, so this brings me to a SQL and a NoSQL question. So let's say you
Yep.
were maybe on a side project or something, you were building an e-commerce application. Would you go for SQL knowing fully well that it's the reliable partner who loves structured and defined relationships? Or would you swipe right for a NoSQL who doesn't believe in schemas and avoids joints?
That's a very good debate actually. So I know NoSQL doesn't support the joins.
I know.
So yeah. So yes, actually, that's the tricky, right? So for any e-commerce,
Yeah.
so the way you do system design is,
Uh-huh.
for example, any e-commerce, the best database for the product data, product images, related information, and everything,
Yeah.
MongoDB is the perfect. So which is
Mm.
like one of the NoSQL. So,
I love
uh,
MongoDB.
but yeah. So, but at the same time, so the user's data. So you have like I told, right, authentication, authorization. Before even you see the cart, you see the search, you need to see the products and everything. You need to have the
Hmm.
user credentials. So that
Yeah.
particular part. can go to a RDBMS, which is, I can say, PostgreSQL, which I'm like, very these days is very popular,
Yeah.
PostgreSQL, and
Yeah.
that open source. And
Yeah.
I have been in PostgreSQL for 8 years.
Mm,
Last 8 years I'm in PostgreSQL, and
right.
I published many articles, and I have some media coverage too for that. So
Okay.
for that particular part, you can use PostgreSQL, and for
Okay.
the rest of the part, the product management and taking orders and all these, like, customers information, all these things can go to
Yeah.
MongoDB, which is like document based, distributed NoSQL database.
Yeah.
And still, where do you store the product images, product videos? So obviously it has to go to Amazon S3 or somewhere. So
Yeah.
what I would say is, like, you have to live with SQL, NoSQL, everything, but
Okay.
where exactly you will fit in, you need to understand the technology and use it in
Yeah.
the right place.
Absolutely. I agree. But when it comes to structured data like spreadsheets and unstructured data like images, which database would you trust to handle different of these data types? Which one? Which database? Because you mentioned Cassandra, you mentioned MongoDB, you mentioned PostgreSQL, you mentioned S3. So which of the database would you trust to handle structured and unstructured data?
Yeah, yeah. If the objects are, like, mutable, there is something called mutable, immutable. So depends
Mm-hmm.
upon that. We need to take it. If it is like, no changes, it's like kind of like an image. So
Yeah.
it's better to store it in a object storage, which is like Amazon S3 or Google storage. So where,
Oh,
so the data is not yeah. Once you put it there, you're not changing. You're just retrieving sometimes. So the financial point of view, the performance point of view, it's better you store there. So if
okay.
it is keep on changing, like, documents keep on changing, like
Yeah.
something like for the document, MongoDB is, the best.
Okay, so great. So unstructured data, MongoDB, and structured S3 for you. That
Yep.
is awesome. It's great to know. So let's say you built an awesome application, and you kind of like just, tossed it into a small 100 gigabytes database. And you were thinking, well, maybe at that point this will do. Maybe you were not thinking about the traction that the application was going to get. Now,
Correct.
fast forward to a couple of months, boom, like it's your application has gotten all of this traction, and you're like, what?
It's our everyday problem. This is like my everyday problem.
Oh, it's awesome.
Because at Apple, I'm not only the database architect, DevOps manager, and all these roles. So my core thing is, like, talking to
Yeah.
the customers, like the end customers at Apple, and understand their problems and provide technical solutions. So that's what, like, I tend to, like, I get a chance to talk to 5 to 10 customers every day. So
Awesome.
believe me, this is a major problem.
Oh, that's
So
that's so now, you've got, so many users pouring in just like it's Black Friday in an Apple
correct,
store, new
correct.
launch for an Apple new phone or
Yeah,
something. And now your database is badly in need of an upgrade because obviously you don't want your application to crash.
correct.
As a database expert, is this scaling up just a quick turn up? Like, is it something you just do quickly? Or are we talking about database with drama and sleepless nights and so many, so many, so many
No.
things?
Yeah. So if it is like 15 years back, yes, that was the issue, but now things change. So
Okay.
you can provide anything on the fly. So thanks to the cloud infrastructure,
Okay.
thanks to, like, the way we emerged database as a service, software as a service, platform as a service, infrastructure as a service, all these things, like, helping us a lot in these situations.
Okay.
But
Yeah.
even but still a decade back, how we used to do, I think it comes under scalability. That is the buzzword these days. So you will have like you will hear vertical scalability, horizontal scalability. So
Mm,
all these things at different layers, like application layer, load balance layer, database layer, everywhere you will hear this scalability. So
okay.
because, so for example, for Apple, so
Okay.
our major business is during December, or
Oh,
during September, where the new products
the
launches.
new
So
products
the
launched.
remaining months, the load is like, it's good load, but
Okay.
the those days the load would be 3x, 4x, 5x, we don't know. So how do
Okay.
you manage, right? So earlier there is something called capacity management. So we try to proactively try to avoid the customer reaching the 100 percentage. We tend to, but still happens, like, even though you plan very well, you take the capacity planning for next 4 5 years, but still it
Okay.
happens. So
Okay.
that's where what I design, like especially in Postgres database, there is something called yeah, I think before going there, so
Okay.
now the Kubernetes is something, helping you, like, dynamically allocate resources. So everybody, like whether it's be it Amazon, GCP, or Azure, all
Mhm.
these guys are providing. So auto scaling is something automatically, it spins up the new instances to take the new load,
Okay.
and that comes under money, right? So then they resolve the problem. So when there is no load, they'll bring it down.
Oh,
So yeah, so that's what called auto scaling, that resolves this issue. But even though nowadays it's called, you will have physical hosts, but there is something called VMs. You will chunk those into VMs, like, virtual machines. But there you
okay.
will have a problem called noisy neighbor. So
Uh-huh.
I wrote a article about this noisy neighbor. So
Mhm.
it's in my LinkedIn. But yeah, so the noisy neighbor is like 10 to 20 people are sharing same resources, but there is one, that resource, or one, that database, one, that application
Okay.
is not planned very well. So even though you planned that, okay, this particular database needs 100 GB, and 8 CPU core, and, like, some 32 memory RAM. So but they also say, like, yeah, that's what but suddenly it jumps in, so
Okay.
without knowing them.
Okay.
So that's called noisy neighbor. So I have written a artificial intelligence kind of, like, programming at Apple level.
That's really good.
So that identifies, oh, this guy gonna become a noisy neighbor. So we
Hmm.
need to put this noisy neighbor somewhere. So before it hits. So we identify the trend analysis, how the transactions are coming, how the database is growing. So before it reaches some certain threshold, so
Hmm.
our job kicks in and says, hey, this is but going to be a culprit, or this is going to be out of space, so out of memory. So we will
Okay.
try to identify before it becomes reality.
Before it becomes a problem. Absolutely. That is so great to know that VMs, Kubernetes, and of course the noise enable you talked about is actually
Yeah,
solving,
and the correct, and the auto scaling is, yeah.
and the auto scaling, which is definitely very good for this. Okay, awesome. So, I mean, we talked about, the scaling of database. Now, as a database engineer, let's say you were building an employee system management, you know, which basically stores everything about employees from their names, titles, their job roles and everything. Now, this engineer has connected a MySQL server, and the connection string is just tight as that of his airport security. Like, so they make sure that the connection string was really good. And the queries that they gave it was perfect. And of course, the code is flawless. Now, but when it came to the time where the engineer tried to pull the data from the database to the client side, a guy was surprised that nothing showed up. And it was like,
Okay.
what's happening here? Why is this not working? Why is this just as empty as my coffee cup after a long debugging session? Or why can't I just see the data that I've already, created a schema for in the MySQL database. And they're so sure that the connection from my SQL database to the application is really good. So
Yep.
what happened? What went wrong?
No, that's how the database issue starts, right?
Okay.
So all of a sudden, it will not work, and you will check like 100 times. You will say, "I did the same thing
It's the same
until this
girl.
time. I did the same thing, but it's not working." So
Yeah.
yeah, there are like multiple reasons could be. So in the interest of time, so the data he is trying to fetch from the database. So there is something called locking mechanism.
Okay.
So maybe there is something locks are happening,
Okay.
or there is something called at network layer. There is something called network packet loss. So
Okay.
maybe the data is like, even the database is giving the data back, but data may be dropping. You need to check with, we need to make sure the network is like, the bandwidth is, accurately, is correct. uh, also uh, Also there could be a limitation sometimes, when you hit some limitation,
Okay.
or sometimes what happens is you try to retrieve data from a replica. So there is something called primary and replica concept. So
Okay.
that's how the scalable database technologies handle. So the primary database is basically uh, for your read rate data, and the replicas are for your, selecting data. That's how they try to segregate, to reduce the load on the primary database. So
Okay.
if that primary and the replica is not in sync,
Okay.
so you might be not getting the data, even though you wrote the data into the primary, but your
Huh?
connection string fetches the data from replica. So if the sync breaks from primary to replica, you are not seeing the real data. You may not be seeing the data too. And also we would suggest, there is something called timeout parameters. So at application layer,
Correct. Definitely.
they need to handle the connection timeout parameters very well,
Okay.
so that they will get the proper errors.
Oh, I see. So how does this data engineer fix this sort of problem where he has done all he needs to do? How would he fix it? What's the
So basically, he needs to talk to the database engineer guy and see like what's going on. So then the database engineer can, check the issue, and he can fix the issue, and get back to him. So what the database engineer does is like, he will try to spin up a connection from outside and see what's going on, to mimic what exactly the application team member is doing.